Hello, everyone. Welcome to Unit 3, Lesson 1. Today, we're going to be talking about geometric sequences. Our goals for today's lesson is we want to make sure that we can identify this thing called the multiplier of a geometric sequence. So we're gonna talk about what a geometric sequence is, and then make sure that we can identify this thing called the multiplier. And then we're also going to identify this other thing called the zero term. And using that information, we're going to want to build an equation for our geometric sequence. All right, and then we also want to learn to make sure that we know how to represent that geometric sequence using multiple representations such as a table and a graph. All right, so let's get right to it. We have a sequence here. So remember, just a sequence is just a list of numbers, right? So we have this list of numbers here, 8, 16, 32. And usually when we show you these lists of numbers, they have some kind of pattern that is happening. And if you examine this and think about it long enough, you'll probably come to the conclusion that there is a pattern here and that it is multiplying by 2, right? So every time we go from one term to the next, it's a multiplication of 2, right? So 8 times 2 is 16, right? So if I go from 8 to 16, we multiply by 2. And if I multiply by 2 again, right? So 16 times 2 is 32, right? And we can use that pattern to help us predict the next two numbers that are going to come in this sequence. And this sequence would actually keep on going forever and ever there. So, and we can keep going using this pattern, right? So if I do 32 times 2, well, we would get 64, right? So 32 times 2 is 64. And then if I did it again, right? So if I multiplied by 2 one more time, we would get 128, okay? So we see the pattern. It's multiplying by 2, and that tells us what our multiplier is. So that number that we multiply by to generate the numbers in that sequence, that is what we call the multiplier, and it's usually represented by the variable b. Okay, so our multiplier here is 2. All right. Now, this term called the zero term. All right, let's talk about that real quick. So when we look at a list of numbers, we would say, okay, this 8 is what we call term 1, right? And the 16 is term 2, and this would be term 3, 4, and 5, and so on, okay? The zero term would be the term that comes before the 8, and it's not actually part of the sequence. It's more of a hypothetical term that would exist if we were to go backwards in our sequence from term 1. Right? So moving forward in our sequence, we multiplied by 2. So if I wanted to move backwards, go backwards one term, we would actually divide by 2. We would do the opposite. Right? So if I did 8 divided by 2, we would get a 4. And this is our zero term. Okay. So we would say A equals 4. All right, and we can actually use this information to help us write an equation that represents this sequence. So any geometric sequence takes on this form, and we represent it with t of n, right? It's just like f of x, but when we talk about sequences, we use t of n, and it kind of indicates that we have a sequence. It's a list of numbers, and it's written in this form, a times b to the n power, right? Where a is the zero term, and b is our multiplier. All right, this last piece, this guy up here, the exponent, this is the term number. Okay, so for instance, if I wanted to know what term number 3 is, I'd put a 3 in for n. If I wanted to know what term number 10 is, I'd put a 10 in for the n. All right, so let's take our information. We know a and b, we just found those two things. Let's put those together and make an equation. All right, so our zero term comes first, right? So we have t of n equals our zero term, which is 4, times our multiplier, which we found to be 2, and that needs to be raised to the n power. Okay, so this is our equation, right? This is the equation that would generate the term values for our sequence. So for instance, let's say I wanted to find term 4. Now we know term 4 is 64, all right? So let's see if our equation gets us 64 when we put a 4 in for n, right? So we would do t of 4 equals, and we would do 4 times 2 to to the fourth power, right? Because we're putting a 4 in for n. It's the input of our equation here. So we're putting a 4 in, and we want to see what we get. Okay, so I'm going to bring up my calculator here, and I want to make sure that I type this in correctly. Okay, so we're going to do 4 times 2, and we need to raise that 2 to the fourth power. So I'm going to use the power button over here on the right. This is the caret key, and it'll put your little cursor up in the exponent part, and then you can type in a 4 and hit enter, and look at that, we get 64. Okay. So our equation worked the way that we expected it to. We put a 4 in, we got a 64 for the fourth term, and we already knew that it was going to be 64 just by using the pattern. So we know that our equation is correct, right? Because it's generating the correct terms of the sequence. All right, so let's try it again. We got one more down here. We have another sequence here, right? So it's going 8, 32, 128, right? And you might need to look at the sequence a little bit and just kind of think, well, we're multiplying by some number, right? This is going to be a geometric sequence, so there's going to be some number that we're multiplying by. And you might do a little bit of trial and error, right? Of like, if we thought, well, maybe the multiplier is 2 again, well, 8 times 2 is 16, not 32, right? So if I did 8 times 3, well, that would be 24. 8 times 4 is 32, right? So it seems like we are multiplying by 4, all right? The question is, if I multiply by 4 again, would I get the 128? So I'm going to test it out real quick in my calculator. I'm going to do 32 times 4, and sure enough, I get my 128. So it seems like the pattern for the sequence is that we are multiplying by 4, right? So over here where it says, what is the multiplier? Well, that is 4. So we would say B equals 4. And then we can keep going with the rest of our sequence. And I'm going to use my calculator to do that, right? So 128, I would take that and multiply it by 4. So we get 512. And then we'll do it again. All right, so we multiply by 4 again, we get 2,048. Getting some big numbers here, and then we got to do it one more time because we got one more. They want us to find one more term, so I'm just going to hit enter one more time. We get 8,192. Okay. So there's the rest of our sequence. We filled in those 3 boxes, and this is what you're going to see on MyOpenMath when you do these problems. They're going to start the sequence off. They want you to predict the next 3 terms by using the pattern here just to continue it. Okay. Now remember, the 0 term is this hypothetical term that would come before the 8, right? So to move forward in the sequence, we were multiplying by 4. So to go backwards in the sequence, we would divide by 4, right? So if I did 8 divided by 4, we would get 2, right? So this is my 0 term. So I would say A equals 2. And then when I go to write my equation, we know it's A times B to the n power, right? So we're going to have 2 times b, which is 4, to the n power. And that would be the equation for this sequence that we have here. All right, now we're going to take this just a little bit further here because in this last question, they want us to actually create a table and a graph to represent the sequence as well. And that's not a problem. So remember, n represents the term number, right? So this is term 1, 2, 3, 4, 5, and 6. So making the table is really easy. We can see term 1 is 8, right? So remember, n represents the term number. T of n represents the term value, right? So term 1 is 8. Term 2 is 32. Term 3 is 128. Term 4 is 512. And I think you kind of get the gist of it here, but we got 2,048, and then we have 8,192. So now we have a table with inputs and outputs, right? So n is the inputs and the t of n, those are the outputs for our sequence, all right? Now when we go to graph this thing, the x-axis down here, this is where our n's are going to go. So you can kind of think of the n's as the x values and the t of n's as the y values. So when I plot this, right, like this first point is going to be at 1, 8, right? Input, output, x, y. And I know on MyOpenMath, they don't have the numbers down here labeled for you. It kind of gets cut off, but you can assume that this here is 0, this is 1, 2, 3, 4, and 5, okay? So this first point that we're going to plot is at 1 comma 8. So I'm going to go right 1 up 8. Notice your y scale here goes up by 8s. So this first block here, this first line, that is where the 8 is going to be. So that's where I'm going to plot that first point. Now the second point is this one. So we got 2 comma 32. Okay, and I'm going to plot that point. So I'm going to go right to, and I'm going to go up to 32. That'll be about right here. Okay. Then we go and we grab this third point. This is going to be 3 comma 128. So I'm going to go right 3 and I'm going to go up to 128, which is all the way up here at the top. And then you'll notice when we get to 4, that goes up to 512. So we go right 4 and then 512 would go well off of this graph. So we do not have to plot that point, just these 3. Okay. And since this is a sequence, we do not need to connect these points. Right? Just plot the individual points from your table and only plot the points that will fit on the graph. All right, and that should complete that problem for you. All right, guys, that's it for today. If you have any questions, make sure you ask in the Zoom chat or schedule an office hour session with us. Have a great day.